um yes, from the title you have seen there, this is a video on how to find error in slope. So I got a request from some students, asked me to make a video on this. Actually, I plan my videos according to the need at a particular time, but I think it's very necessary that we all do this together. Now, if you check the solution material by the Young Modulus, you notice that I've also explained how to find error in slope in one of the graph, in one of the experiments. That should be M8 experiments. But the truth is that if you don't have somebody guiding you on the, you'll not be able to get the whole thing very clear. So that's why there is need for you to have video of this form. Is that okay? So that is why I decided to make this video, because even though I explain that part for you, without video like this, may not actually follow. Like this morning, being the 20th of March 2024, a student called me this morning and I was trying to explain to her, and she said, "Sir, please, can you send me the?" I said, "No, it's not something I send. Rather, I have to send a video, all right, to you, which is what I'm actually doing here." So I believe that student is also seeing what I'm doing here. All right, so that is that. So I want to assume that you have plotted your graph. Okay, so we want to look at the major focus. Yes, I will also do a video on how to plot graph, on how to find slope normally, but my major focus in this video is how to find error in slope. Okay, so you just follow me. From the error in slope, you can also calculate error in your R, and then error in other variables as expected. We have other formulas you can use, but this very formula we want to use here is a much easier one. Okay, so like I said, I want to assume that you have plotted your graph, or you know how to plot graph, and you have also um, done your slope. You have also calculated your slope. So in that this is, so now from that existing protocol, we can start up with this. Okay, so this is our graph. Okay, I didn't have a graph sheet around me here, but like I said, I want to assume that you know how to plot graph. And if there's a, this is our graph, and I've taken my line of best fit. I have reason why I took this line of best fits, so that it will enable me explain some things I need to explain. Now, what is the line of best fit? This line you are seeing here is a line that at least that cut across a minimum of 3 points and a maximum of any number of points you can, or you have, such that some point fall this way and the other way, so that you have some points this way and the other way. What does this actually means? It gives us a signal, okay, because there was something I discussed with that student this morning when she called. um, she told me that well, when they plotted their graph, all the points did not enter. Maybe I feel they wanted all the points to enter. I said no, all your points must not enter. Please, physics graph is not mathematics graph. Okay, mathematics graph, there are cases that there's a formula given to you already, an equation given to you. All right, so there's a pattern which you follow. But in a physics graph or physics experiment, you don't control the values you have, and that's what we talk about random error. So there's certainty, there's that probability, which is 100%. Okay, that there's going to be error in your experiment. That's why they normally ask to find error in graph, error in G, and error in that. Okay, so don't think that all your points will enter, and that's why we define the line of best fit as a line that at least it will cut across minimum of 3 points. The least should be 3 points. So with 3 points, what you do is that you are going to station or arrange your points, your best fit, or your meter row, okay, so that you have your 3 points. Like I said, I want to assume that you know how to plot this graph already. So you may have some points scattered all over. So your own work is to now see a way you can adjust it such that you have your 3 points that entered, or more than 3 points. Okay, but it mustn't be all of them. Well, if all of them enter, there's no problem. Okay, so, and it's also good you understand that when you are trying to manipulate, because they manipulated their value, and when they did that, they put all the points inside the line of best fit, which is not okay. All right, so even though you are manipulating, you must also work with the standard. Okay, so that is so. Now in that experiment M8, I'm using that as a sample, please. In that experiment M8, okay, you are expected to have, I think, about 5 points. Okay, about 5 points. Now let's assume that among those 5 points, okay, among those 5 points, I have these points that entered. I will use my red pen. I hope this pen is writing. I have these points that entered. Okay, then let's assume that another point entered here, and then another point entered this way. Okay, so by right now, let's assume that I decide to take my slope here. Now let me say something about taking your slope. Taking your slope must not be endpoint the size of the length of the triangle that you're going to get, and you expect to take a bigger slope, you understand. But for this very work, I will just take endpoint to endpoint. So let's assume that this is where I take my slope. Okay, so this is where I take my slope. So if you have issue with taking slope or how to calculate slope, okay, taking scale 2 of a graph, make sure you check other of my videos concerning this. Okay, so just permit me to do that. Let's assume this is the triangle I've taken, which I'm going to use to take my slope. Okay, so I'll get that. Let's assume that our slope, okay, remember, you don't do it on a graph sheet. I'm just doing it because I'm trying to explain a few things here. So let's assume that our slope is let's say, yeah, of course, change in t square all over change in L. Change in t square all over change in L. So we shall have here to be, you trace out these points. Okay, that is your 6 minus trace out these points. It should be about 3.2. Okay, or 3.5. Let me just say, okay, it's not up to 3.5. Let's say 3.2. Then all over these sides should be about 55. Okay, about 55. If we trace it down, about 55. Okay, if we trace it down, then if we trace here down, okay, that's about let's say 18 or 17. Okay, or let's say 15. It's more than that. Okay, let's just say it is an assumed value. So that is how to take your slope. I will do a video on that properly. So this is about 2.8 divided by 55 minus, that is 57. That is about 47 at 37. So we have here as 37. So if we divide that, let's assume that we are getting 0.65. All right, so please, I'm just doing an assumption. I just have to prepare this video this morning. I didn't prepare for this, but let me just do this so that every person that has similar question can be able to follow up. So that is just that. Now my major concern, like I said, is my error in slope. Now let's assume that we have about 5 points in that graph, and then I was able to have my 3 point that entered. And then please listen to this section of this explanation, because there's something that we have that may not be true for everybody. Now let's assume that, like as we said, the line of best fit should be drawn such that we have 3 points and then some point that fall this way and the other way, this way and the other way. Okay, so now what happens if all your point falls on one side? Let's assume the remaining 2 points or 3 points fall on this side or this side. What do? You are going to do something unique, and that is you are going to do some kind of manipulation on that. All right, so if I assume that, let's assume that all my points fall this way and this way, instead of falling this side and this side, I'm going to shift one of them. I'm going to clean one of them and put one of them here to enable me find my error in slope, even though you cannot find your error in slope, meaning that your line of best fit was not placed in a normal position. That's the implication. That's the meaning of that. Is that okay? So that's one point you need to know. And then the second point again we need to know is, in a case where your points, okay, let's assume that I have 3 points that fell outside the line of best fit, and let's assume that one is properly here, and then the other one is this way, and the other one is this way. Are you seeing that? So what then do we do? All right, now you place your meter row. Very, very important. You have to place your meter row. Your meter row has to be parallel to the line of best fits. Your meter row has to be parallel to the line of best fits. So you place it parallel to the line of best fits. Place it parallel to the line of best fits. Okay. Ensure you place your meter row parallel to the line of best fits. Okay, I'm going to show you that. Let me just finish up this. Okay, let me just do this. I'm going to reverse the camera. I just want to get this out first. So check this. Let me reverse the camera. You will see what I've just done here. So you can see that the line of best fits, so the dotted line I draw across here is parallel to this line of best fits. You can see it here, parallel. It should not be in a V shape. It should not be W shape. If not, yes, it should not be something like this, where you have your line of best fit and you draw something like this, then come and draw another one again, as if you are moving from a Port Harcourt to Aba Road. It shouldn't be like this. This is wrong. Okay, I will show you the implication of doing that. Then the second one, now this is where the challenge is now, and most people have challenge with it. I saw a video on YouTube where one of the guy made this mistake. So please, if it comes across this video, the best way of getting this is now the points that we choose is the point that is farther away from the line of best fit, not this one. The guy took this one. It is not this, but it is this one, because we want to cover every point in that graph. Okay, so we need to cover every point in that graph, except that the point is far like it's just too far from here. Let's assume I have a point here. My knowledge of my practical work, okay, experiment, I should know that any point that I have here against what I have here, that point should be discarded, so I don't need to take it. But if you have a point around this region, okay, around this area, then it's manageable, it's okay, that means it's close. What I mean is that in the case where you are doing an experiment and you got a value like 1, 2, 3, 4, 5, and then the next value become 50, you should know that there's something wrong with that 50, so you discard it. So what I mean is that for this point that are very close, I have to pick this very point here, okay, that is farther away from this very graph, this very line of best fit. So that's the one you pick. Okay. All right. So let me do that before I return back to give you my listing. Okay, so I'm doing that now. I will show you the camera so that you can be able to compare what I'm doing here with is expected. All right, so I've just done that here. All right, so you can see that I took the other line that is far from this line of best fits. You can see that very well. Okay, now the next thing is for you to do is for you to now take your what you call vertical scatter. Now most of the major vertical scatter this way. That is wrong. It is called vertical scatter, not horizontal scatter or oblique scatter. This is oblique, this is vertical. So you draw it, okay, with your meter rule, okay, you draw it from this dotted line to this dotted line, okay, from this dotted line to this dotted line. I'm coming now. I've locked my orientation. Hold on. Okay, so it must be done. I'm coming. I went and locked my rotation. Okay, that means you are going to slant. You are going to slant. Sorry, you have, yeah. I'm coming. Oh my god. What did I just do? Okay, so I believe your camera, your video should be showing very well there. Okay, so if you're not showing very well, you have to put it in landscape. I don't know, because my own is showing something which I didn't expect here. All right, so this is what we have here. This is what we have here. So you can see that scatter is taken from this line to this line. It's a vertical line that is taken from the other dotted line to this other dotted line. Now imagine where you come here and you want to take a vertical scatter from what I said earlier. So if you draw a straight line like this, and draw like this, you notice that the line are not the same. But for this one here, anything I draw here, draw here, draw here, any point I draw here, here, I will have the same thing. But it's advisable you draw it just where you took that triangle. Are you okay now? So you do that. So once you are done, how do you get this W? We call it W. Actually, before I continue, this is the formula we use. Error in graph. Okay, error in graph. I will see do a final video on this. I'm just trying to get to answer this question because I have so many questions on my comment section. Sorry, on my DM in my WhatsApp on how to do this. So this is the formula we are using for our formula for error in graph. This formula that we are using, okay, where W is a vertical scatter, and then Rn is a number of plotted points, which is about a 1 2 3 4 5 6 for me now I have 6 here. Then R is a horizontal range, so this is your R distance from here to here, which is the same thing as your 0 point, sorry, 37. Are you there now? Then the next thing you have again, yeah, I've been explained that. So how do you get that this is a vertical scatter? So to get a vertical scatter, you trace to this side, then trace this one to this side. So this is almost like having 4 into this point here is 5. That's the highest minus the lowest. Then this point here is about 3.5 divided by number of plotted points. I have 6. Then times R. Our R is our 37. Have you seen it? So whatever thing you get here becomes your error in R, error in graph. So let's assume that the answer we have here is 2.5. For example, assume the answer we have here is 2.5. Are you there? Assume the answer we have here is 2.5. I don't have my calculator here. So let's assume the answer we have here is 2.5. Then how do you put your final answer? Your error in slope will become your slope, which is this value we calculated, 0.65 plus or minus your error in graph, which is what we got here as 2.5. Okay, now if you're calculating error in your R, your error in your R is now going to be half of your error in graph all over what your R. Okay, that is your this in there, half of your error in graph, although we have other formula we can use to calculate error in R. Okay, so but this is the simplest formula you can use to do that. Okay, so like I said, my major concern here in this video is to calculate error in slope. Okay, that is my major concern here. I will make some other video, a cleaner one, so that I'll be able to get every detail. So as a review, going back again, I said draw a dotted line, sorry, a line of best fit. Then those points did not enter, draw the dotted line across them, and it's very far in case you have more than 2 on this side or more than 1 on this side or this side. Then draw a vertical scatter, not this way but vertical. Then what the next thing is that you measure, okay, to get a vertical scatter you get this way, and then this side subtract their 2. That's all. Then your R is this base of your triangle, then end the number of plotted points. Now some person took only the points that enter this line and say no, it is all the points that you use in that your experiment. Okay, that is in your table of value. Okay, so for now, I'm going to end the live here. If you have any question, please drop it on the comment section or check my WhatsApp 09157293443, and then ask me question there. I'm going to answer you. Okay, so like I said, I'm going to make a cleaner video more than this, but for now, please, I don't really have much time. Work with this. Work with this for now. If you have any question, just ask the question, and then I'll be able to put you clear. But I think the video will go a long way to help those of you that actually know what you are doing. All right, thank you, and see you in my next video. So please don't forget to share, don't forget to like, don't forget to share the videos, friends, like that. Okay, I want to end this. Safe light smooth enable flash. Yeah, this is what I was looking for. It's now that it's coming up.